Picturesque programmers, it's Prof G, and we're going to extend our BipTheGuy app by adding the SwiftUI Native PhotosPicker. That's going to allow users to select their own images to BIP. And while we learn about the PhotosPicker and related data types, we'll learn how to convert a PhotopickerItem into a SwiftUI Image View. We'll work with the loadTransferrable method. This is our first async method. We'll also learn how to add an entire view to a variable for easy updating. And along the way, we'll learn the difference between try and try question mark. I can picture more big learning. Let's code. If you're new here, welcome. Check out the playlist to see how we got here. So the view we're going to work with is the SwiftUI PhotosPicker. And like our code for playing sound, since most SwiftUI apps don't use the PhotosPicker, the PhotosPicker isn't built into the core SwiftUI. We have to import it. And we do that with the statement import photos UI, note the caps. Now the PhotosPicker view is going to return an image that the user selects, and this is a special type called a PhotosPickerItem. So we need to declare a variable to hold that selected photo. And since this is going to change as our code runs, it's got to be a state variable, so we'll say @state private var. We'll call this selected photo, lower camel case, and we'll say colon, then pass in the type for our declaration, which is PhotosPickerItem. Code completion says this is a type that represents an item you use with a PhotosPicker, and we're going to put a question mark at the end. The question mark means that this is an optional, meaning it could be nil, and it is nil when our app starts because we haven't picked a photo yet. Now the type here is going to be important. A PhotosPickerItem can pick anything that's in the iOS PhotosPicker. That could be images, but it could also include video and some other types. Now what we're going to want to do is we're going to want to restrict what the PhotoPicker shows so it's only images, because we're only using images in this app, and we're going to need to convert this PhotosPickerItem type to just an image view so that we can show this in our app. So now let's add a PhotosPicker view so our user can pick an image. And we're going to do this by replacing our button. The PhotosPicker includes a button, so we'll be able to reuse the buttons label that we wrote before, but there's more to this PhotosPicker. So just above the button, below the spacer, enter PhotosPicker and use the arrow to highlight the option with selection and label in standard type. Code completion says this creates a picker that selects an item and optionally configures the types of items to show, item encoding, and label behavior. So press return to accept this. Note this wants a binding to a PhotosPickerItem, and we just created that variable so we can enter $selected photo. Then tab over to label, press return for the trailing closure format for our label code. Then we can highlight the label code that we wrote down in the button, copy it, then paste it in the closure for the PhotosPicker, and we can delete our button. And we see we have a Photos Library button at the right, but this comes in through the PhotosPicker, not through the old button code. And by the way, you can add a button style modifier to the bottom of a PhotosPicker if you want to change it to, say, bordered prominent or another one of the button styles. But for now, let's click this, and look at that. The preview shows us the standard iOS image picker with the 6 photos that are in the default Simulator Photos library. Very cool. Well, we're almost there, but if we click any of these images, the PhotoPicker will dismiss, but we haven't done anything with the selection. So you can either click an item or click cancel, it won't matter. And let's add a little bit more code to our PhotosPicker. There are a few additional options that we could use here. Let's add a few. So after the selected photo binding variable, enter a comma before the close parenthesis, and we'll type the word matching. Code completion says this is a PhPicker filter. That's an optional value, see the question mark at the end. We'll press return, code completion adds the colon after this argument label, and so what are these picker filters? Enter a dot, and what we see here are a bunch of different types of media that might be in our photos library. Images, bursts, cinematic videos, live photos, panoramas, and a whole lot more. Well, for our app, we just want images. So if we select images and press return, we filter out all of the other options that might be in a photo library, but we can't use in this app. This is great because it won't even present those other options to the user. Next, I'll type a comma, enter the word encoding, select preferred encoding. This wants something called an encoding disambiguation policy. Press return to accept this, press dot to see the various options. There are a bunch of different options in here. We'll select automatic, although frankly, we didn't even need this parameter since automatic is the default option. Automatic just means that iOS is going to select the best encoding for the selection. Now, when the user makes a selection, they're going to return a PhotopickerItem. How do we use that PhotopickerItem? Well, we can set up an onChange modifier. Remember, we learned how to use that in the Word Garden app. We used it on a text field. Well, we're going to use it here on a PhotosPicker. So enter onChange. There are 2 options in here with of and action. You want one of those, but not the one with equatable and equatable after the action. You want the one with the empty parens after the action. That just means that it doesn't pass anything into the closure. If you select the equatable one, just delete the 2 values that show up and the in keyword. So press return to accept this, And remember, the of value in here is the value that we're watching for a change. And we want to put selected photo in here, since this will be the selection that the user has made via our PhotoPicker. And then I'm going to tab over and I'm going to press return to get the trailing closure format. And so now that we've got this set up, what do we do in this closure? Well, we want to take what's inside of the selected photo that we just got back and put it inside of the image view. Let's look at the image view. Right now we're setting this up by passing in a string. And even if we can change this string from a literal value to a variable that holds a string, that still doesn't do us any good, because the PhotosPickerItem doesn't come back as a string, it comes back as some data called a PhotosPickerItem. See, if I option click on selected photo, it says its type is a PhotosPickerItem. Well, here's what we can do. We can create a variable that will hold not simply the string, but the entire image view. And it's totally okay to do this. An image view is just a type, like a string or a double. It's a bit more complex of a type, but we can put an image view into a variable just like we can with a string or a double. And we do it like this. We can say @state private var, why don't we call this BipImage, lower camel case, and we'll set this equal to image, parens, and the string clown. This is totally valid to do in SwiftUI. Then we can replace the image declaration down here with our BipImage variable, and now when we want to change this image, we'll change BipImage, not just the string. So down here in the onChange modifier for the PhotosPicker, what we want to do is something like this. BipImage equals image, passing in selected photo. But unfortunately, SwiftUI does not yet have an easy way to convert from a PhotosPickerItem into an image. And this is what we're about to do. To the slides. Now we're about to write some code inside the onChange modifier, and this might seem a bit gnarly because there are a few things that we haven't seen before, but I'll do my best to describe them, and the code that we write is going to be very reusable, so you should be able to repeat this technique in any app that you want to use a PhotoPicker in, just swap out different variables. So first, to be clear, the PhotosPicker will update our selected photo variable to contain the user selection. So when the photo has been selected, the closure in onChange will fire because the selected photo has changed. Now here's the tricky part. Selected photo is a PhotosPickerItem. That's its data type. But what we see on screen is an image, a completely different data type. We can't simply do the conversion by putting the word image with parentheses around selected photo. That's not going to work. But we can use a special method called loadTransferrable, which will try to extract data from whatever we put in the type value here. And if we specify the image type, we do that with capital I image.self, then this will grab the image data from the PhotoPickerItem and store it as an image view. So we can take that image view we just extracted and assign it to our BipImage. Then our selection will show up in our app. Now there are two really important things to pay attention to with loadTransferrable, and we see them both in code completion. One is it says that this throws, meaning that if there is an error, it'll throw the error, which can be caught and dealt with. So we should use a try statement with this, and up until now we saw that we use try with do catch, but I'll also show you a new technique with try ? Now the other thing is this also includes the async keyword. We haven't seen that before. Now an async function is code that will execute without holding up the rest of the code. It lets the rest of the app continue while it waits on a result to come back. Let's think about a real-world equivalent. If you and a friend are in a line at a movie theater, you might tell your friend to go buy popcorn while you wait in line for tickets. This way, you're both not slowed down waiting for the tickets. Well, async functions are the same way. Functions that might take a while are labeled in Swift as async functions. They have the await keyword out front, and they're surrounded by curlies inside of a task block. This tells Swift to move on with the rest of the code without being held up, and the code inside the task block will be completed on its own when it's ready. So we say that the task block runs asynchronously as opposed to synchronously, where we would wait for the result to come back before continuing. Now this is really useful if a function is being performed that might take a bit of time to complete. A good example of that is if we're getting data over the internet. Now we're not really going to notice our app with very much delay when it tries to convert the PhotoPicker data into an image, but we're going to use a function named loadTransferrable. Code completion names that as an async function, so we need to put the keyword await in front and wrap this inside of a task block. Now we can write this code a few ways. Here's one that uses do, try, catch. Now remember, since loadTransferrable throws, we have a try before we call loadTransferrable, and we put this in a do clause. And if loadTransferrable throws an error, then we catch the error down here and we deal with it in the catch curlies. Now, since this is an async function, we have the keyword await, and that's between the keyword try and selected photo, the variable we're using to call loadTransferrable. And also notice that this entire block of code is wrapped inside of a task block with a capital T Another thing we need to do, because loadTransferrable is an async function. Now, I also mentioned I'd show you an alternative to try. Try is used for anything that throws an error, and if it throws an error, we catch the error and deal with it in the catch part of a do-catch clause. Now, if we don't care about the error, then we can use try ? Instead, and this just ignores the error. The error is treated like nil. So what we're doing here is we have try ? If it works, great. The guard lets us through. If it doesn't work, we get a nil value, and we return via the else clause in guard. And while you don't have to add a print statement, I did anyway to report the error, sort of like what we would normally do in a full catch clause. So there are actually 3 types of try, and here's your overview. Use plain try when you care about the error that's thrown. So if you use this, you need to use a do catch clause, and you can deal with the error thrown inside the catch clause. It's going to be called error, all lowercase. Now use try ? when you don't really care about the type of error thrown. You're not going to get back that variable error. You don't care what's inside of it. You just want to know if an error occurs or not. So if you don't care about that error variable, try ? is a good choice. You'll still know if an error was thrown, and you can react to it. You just don't need the error. And instead of do catch, you can use try ? with guardlet or iflet. Now there's a third variety, try ! I don't recommend you ever use this. It's like force unwrapping a value. If an error occurs, it crashes your code. It only makes sense if you're testing, never in production code. Now back in Xcode, let's convert our selected photo to an image. So we can delete this line here where we assign a BIP image to an image containing selected photo. That won't work. And instead, let's try to put the converted image into a value that we'll call selected image. So we're going to create a new constant here. And this is how we'll do it. We'll say guard let selected image, our new value, equals selected photo. That's what we got back from the PhotosPicker. Remember, this is of type PhotopickerItem. And we'll convert this to an image using the .loadTransferrable function. Now, code completion for loadTransferrable isn't very user-friendly, but essentially what this does is it extracts data from whatever value it's attached to. We're using selected photo, which is of type PhotopickerItem, and we can convert this to the data type that we pass in through this type parameter here. So now look at this. This function both throws, so we need some kind of try, and it has the async keyword in here. So we're going to need to put the keyword await in front of the function, and also we'll need to take the whole block of asynchronous code and embed this in a task block. So this is a really useful skill to remember. If you see throws, you know you need some kind of try. If you see async, you know you need the await keyword out in front of the function, and you need to nest any code that you want to run asynchronously inside of a task clause. So press return to accept this. And we'll first add the type that we want to convert our extracted data to. So that's going to be capital I image.self. Now when we say image.self, we're telling SwiftUI that we want to refer to the type of an image view. We're not creating a new image view that we would view on screen. Then, since this throws, but I don't care about the error value that would show up if the error was thrown, I'm going to add a try ? out in front of the selected photo.loadTransferrable call, and also make sure that you use else and curlies and return inside of the curlies at the end of the guard let statement. And to alert me if there was an error thrown, I'll add a simple print statement in the else clause above the return statement that says print error could not get image from loadTransferrable, and I'll add an angry emoji out front. Now I'm still getting an error here. Click on the little red ball of anger, and you see a message that says async call in function that doesn't support concurrency. Translation from engineer speak, this means that we haven't dealt with the fact that loadTransferrable is an async function. So we'll add the keyword await between try and the call to selected photo.loadTransferrable. Then we wrap the whole guard statement in a task block. So to do that, I've highlighted the whole guard statement, and to put it into curlies, I'll type the open curly, Xcode adds the closing curly and indents this, and then I can put a capital T task in front of that open curly. And then I'm done. My errors go away, but my code isn't done. What should I do if the guard let statement works, which should happen most of the time? Well, I'm going to take the BIP image variable, which initially is going to hold the image view containing a clown, and I'm going to set this equal to selected image, that constant that we created in the guard let statement up here when we extracted an image from our selected photo using loadTransferrable, and so this should work. And now for our moment of truth. In preview, let's click Photo Library. We see the photo library. None of these are things that I particularly want to BIP, but let's imagine that yellow leaf is getting all up in your grill trying to make beef. So select that, and hey, we see the image updates in our image view. Let's BIP that leaf. Ha! Take that, nature boy. Now let's click the play button and try this in the simulator. Hammer time, no errors. And why don't I show you how you can add your own images to the simulator? So I'll click Photos Library in our app, the library shows up with these same images, but I've got an image of the coronavirus on my desktop. It's in a JPEG, so I'll head over to the Finder and I'll drag this image right into the library that was displaying on my app. And I can see the coronavirus shows up in here. Now, the first time you try to double-click that image, you might get a bunch of messages about notifications and whatnot, but you'll eventually see, yep, it was added to the simulator's photo library. Now, let's see. I'll click the BipTheGuy arrow in the top left to go back to my app, and I don't see the new image showing up here yet. What if I double-click the home button up top, swipe away the Photos Library app, get back into the BipTheGuy app, and there it is. So I can see my simulator now contains the coronavirus image, and that image will stay in this particular simulator. Now remember, each particular device that you simulate, or even each operating system that you try to simulate in the simulator, is considered to be a separate virtual device. So it's not going to exist on any other device or operating system versions you try to simulate. You'll still need to drag images over to those versions. And the only way it'll go away is if I delete that image, or if I head under the device menu and select Erase All Content and Settings. So that image isn't in your app, but it is part of the simulator. So let's click this, and look at that. It adds right into our app. Ooh, I want to give that thing a bip. Nice. Let's click on Photos Library. Maybe you got something against waterfall. TLC says don't go chasing them. Take that. So that's it, Swifter. Now you could do more with this app if you'd like. You might, for example, want to put rounded corners around your image. I don't like to put a shadow on this image because if you use an image with a white background, I think it shows up nicer. But you might want to do this if you tend to bip more photographs. But in this lesson, we did accomplish lots of big learning. We learned how to add a SwiftUI PhotoPicker to our app. We learned that it returns a PhotosPickerItem, but we learned to use the loadTransferrable method to convert a PhotosPickerItem to an image view type. We learned about async functions that require the keyword await and also need to be inside of a task block. And we learned about 3 different versions of the try statement. Want one of those My Mac Builds app laptop stickers? Record a short video of you bipping something in an app that you built in this series? Blue Sky or Mastodon post at me with the hashtag #BuiltWithProfG, and if you're selected, I'll mail that out free anywhere in the world. Keep hacking, Swiftmeister. Your sauce remains awesome.